Space travel has always captured the imagination of humanity. From the earliest days of stargazing to the modern era of interplanetary exploration, our journey beyond Earth is a story of ambition, innovation, and courage. In this video, we'll trace the remarkable history of space travel, beginning with the launch of Sputnik and culminating in the ongoing missions to Mars. Let's embark on this cosmic adventure together, exploring the milestones, challenges, and triumphs that have defined our quest to reach the stars. October 4, 1957, the Soviet Union launched Sputnik 1, the world's first artificial satellite. This small beeping sphere marked the dawn of the space age, sending shockwaves around the globe. Sputnik's success demonstrated the feasibility of spaceflight and ignited a fierce competition between superpowers. The launch not only showcased Soviet technological prowess, but also inspired a generation to look skyward, dreaming of what might be possible beyond our planet. Sputnik's launch triggered the space race, a period of intense rivalry between the United States and the Soviet Union. Both nations poured resources into developing rockets, satellites, and spacecraft, each determined to outdo the other. This competition accelerated technological advancements and set the stage for some of the most iconic moments in space history. The world watched as the two superpowers vied for supremacy in the ultimate frontier. April 12, 1961, Soviet cosmonaut Yuri Gagarin became the first human to journey into outer space. His spacecraft Vostok 1 completed a single orbit around Earth, making Gagarin an international hero. His famous words, "Poikali," meaning let's go, symbolized the spirit of exploration and the courage required to venture into the unknown. Gagarin's flight proved that humans could survive and work in space, paving the way for future missions. Response to Soviet achievements, the United States launched the Mercury and Gemini programs. Mercury aimed to put an American in space, while Gemini focused on developing skills needed for lunar missions such as spacewalks and orbital rendezvous. These programs produced a series of firsts, including the first American in space, Alan Shepard, and the first spacewalk by an American, Ed White. Each mission brought NASA closer to its ultimate goal, landing on the moon. July 20, 1969, Apollo 11 achieved what was once thought impossible, landing humans on the moon. Neil Armstrong and Buzz Aldrin became the first people to set foot on the lunar surface, while Michael Collins orbited above. Armstrong's words, "That's one small step for man, one giant leap for mankind," echoed across the world. The Apollo program demonstrated the power of human ingenuity and the potential for peaceful exploration beyond Earth. For the Apollo missions, NASA introduced the Space Shuttle, a reusable spacecraft designed for frequent trips to low Earth orbit. The shuttle enabled the construction of the International Space Station, deployment of satellites, and scientific experiments in microgravity. Over 3 decades, the shuttle program expanded our understanding of space and made it more accessible, though it also faced challenges and tragedies, such as the Challenger and Columbia disaster. Space exploration gradually shifted from competition to collaboration. The International Space Station, ISS, launched in 1998, became a symbol of global partnership. Built and operated by multiple countries, the ISS serves as a laboratory, observatory, and home for astronauts from around the world. This spirit of cooperation has led to shared knowledge, joint missions, and a greater understanding of our place in the universe. While humans have ventured only as far as the moon, robotic spacecraft have explored much farther. Probes like Voyager, Pioneer, and New Horizons have traveled to the outer planets and beyond, sending back invaluable data. These missions have revealed the wonders of our solar system, from Jupiter's storms to Pluto's icy plains, and have inspired new questions about the universe. Mars has long fascinated scientists and the public alike. Its similarities to Earth and the possibility of past or present life make it a prime target for exploration. Over the decades, numerous missions have been sent to Mars, including orbiters, landers, and rovers. Each mission has brought us closer to understanding the planet's history, geology, and potential for supporting life. 1976, NASA's Viking 1 and 2 became the first spacecraft to successfully land on Mars and send images back to Earth. These landers conducted experiments to search for signs of life and analyzed the Martian soil and atmosphere. Although no definitive evidence of life was found, the Viking missions provided a wealth of scientific data and set the stage for future exploration. Mars rovers have revolutionized our understanding of the Red Planet. From Sojourner in 1997 to Spirit, Opportunity, Curiosity, and Perseverance, these robotic explorers have traveled across the Martian surface, studying rocks, searching for water, and even collecting samples. Each rover has faced unique challenges, but their discoveries have transformed our knowledge of Mars and its potential to support life. Launched in 1990, the Hubble Space Telescope has provided breathtaking images and groundbreaking discoveries. Orbiting above Earth's atmosphere, Hubble has observed distant galaxies, nebulae, and planets, expanding our understanding of the universe. Its contributions to astronomy are immeasurable, revealing the beauty and complexity of the cosmos. For the ISS, space stations like Skylab and Mir played vital roles in long-duration spaceflight. Skylab, launched by the United States in 1973, allowed astronauts to conduct experiments in microgravity. Mir, operated by the Soviet Union and later Russia, became the first modular space station, hosting international crews and paving the way for future collaborations in space. Women have made significant contributions to space exploration. Valentina Tereshkova became the first woman in space in 1963, and since then, many others have followed, including Sally Ride, Mae Jemison, and Peggy Whitson. Their achievements have inspired future generations and demonstrated that space is a frontier for all humanity. The 21st century has seen the rise of private companies in space exploration. Firms like SpaceX, Blue Origin, and Virgin Galactic are developing new rockets, spacecraft, and technologies. Their efforts have lowered costs, increased access, and sparked renewed interest in space travel. Private spaceflight is opening new possibilities for research, tourism, and even future colonization. One of the most significant innovations in recent years is the development of reusable rockets. SpaceX's Falcon 9 and Blue Origin's New Shepard have demonstrated the ability to land and reuse rocket stages, dramatically reducing the cost of spaceflight. This breakthrough is making space more accessible and sustainable, paving the way for more frequent missions. A major goal of current Mars missions is to collect and return samples to Earth. NASA and the European Space Agency are working together on ambitious plans to retrieve Martian soil and rock. These samples could answer fundamental questions about Mars's history and the possibility of life, marking a new era in planetary science. Sending humans to Mars is one of the most ambitious goals in space exploration. NASA, SpaceX, and other organizations are developing the technology and plans needed for such a mission. Challenges include long-duration spaceflight, life support, and landing safely on the Martian surface. Despite the obstacles, the dream of setting foot on Mars continues to inspire scientists and the public alike. Space tourism is no longer science fiction. Companies are offering suborbital flights and planning future trips to orbit and beyond. Early space tourists have already experienced weightlessness and seen Earth from above. As technology advances and costs decrease, more people will have the opportunity to experience space firsthand. The central question in space exploration is whether life exists beyond Earth. Missions to Mars, Europa, and Enceladus are searching for signs of life, past or present. Discovering even the simplest organisms elsewhere would have profound implications for science and philosophy, reshaping our understanding of life in the universe. Space telescopes like Hubble, Spitzer, and the James Webb Space Telescope have revolutionized astronomy. By observing the universe from above Earth's atmosphere, these instruments can detect faint and distant objects, study exoplanets, and peer back in time to the early universe. Their discoveries continue to expand our cosmic horizons. Mars exploration is a truly international effort. In addition to NASA, agencies from Europe, Russia, China, India, and the United Arab Emirates have launched missions to study the Red Planet. Each mission brings unique perspectives and technologies, contributing to a global understanding of Mars and its mysteries. SpaceX's Starship is designed to carry large crews and cargo to the Moon, Mars, and beyond. With its fully reusable design and ambitious goals, Starship represents a new chapter in space transportation. If successful, it could enable regular missions to other planets and make interplanetary travel a reality. NASA's Artemis program aims to return humans to the Moon and establish a sustainable presence there. Artemis will land the first woman and next man on the lunar surface, test new technologies, and prepare for future missions to Mars. This program marks a new era of exploration and international cooperation. Traveling beyond Earth's orbit presents many challenges. Astronauts must contend with radiation, isolation, and the need for reliable life support. Developing solutions to these problems is essential for future missions to Mars and beyond. Overcoming these obstacles will require innovation, resilience, and international collaboration. As more satellites and spacecraft are launched, space debris has become a growing concern. Collisions with debris can damage or destroy valuable equipment and threaten crewed missions. Efforts are underway to track, manage, and eventually remove debris, ensuring the safety and sustainability of space activities. The future of space travel holds endless possibilities. Advances in propulsion, robotics, and artificial intelligence will enable new missions and discoveries. As humanity continues to explore, we may one day establish colonies on other planets, mine asteroids, or travel to distant stars. The journey is just beginning. Space exploration drives technological innovation, inspires curiosity, and unites people across borders. It helps us understand our planet, search for life elsewhere, and push the boundaries of what's possible. The quest to explore space is a testament to human ingenuity and our desire to reach for the stars. From Sputnik's first beep to the latest Mars rover, the history of space travel is a story of determination, discovery, and hope. Each mission builds on the achievements of the past, opening new frontiers for future generations. As we look to the stars, we are reminded that our journey is far from over, the adventure continues, and the universe awaits.